Hi, everybody. Welcome. It's Alex Jarett and Technology Executives Club. We have another edition of our Technology Executives Review video show and podcast. Be sure to watch all of our videos at technologyexecutivesclub.com. You can listen to them at our podcast under Technology Executives Review on Apple or Spotify or our site. And today's topic is AI and data in manufacturing. I'd like to introduce you to both Nathan Rajen and Prabir Chatterjee. And Nathan, hi Nathan, he's the CISO.
Hi everyone.
Good to see you here, Nathan. Nathan is the CISO and former CIO CTO at Joyson Safety Systems. So it's great to have you here, Nathan. And Prabir is the CTO of a company called SPAATech, and he was previously in charge of data for Spencer Gifts, as well as a big company called Serva. So hi Prabir, how you doing?
Good. How are you, Alex? Thanks for having me here.
Thanks for being here. We appreciate both of you. This is such a cool topic. I've never worked in a manufacturing company, but obviously everything around us is manufactured. And I've read a lot of articles, and Nathan and we did interview. We just did a recent board of advisory interview. That was just pretty recent, right? A couple months ago.
Yeah.
And Nathan's entire career, not entire, but a big chunk of your career has been in manufacturing. You've been in consulting, you've been internal. I remember Nathan actually told us the story of how he was involved in CAD CAM and computer-aided design that changed how cars were made. Remember when you were at Ford, you told that story.
Yeah.
And he was on that.
Late 90s, yeah, that was a major transition for automotive manufacturers. Yes.
Major transition. And now you're at Joyson, and he's one of those rare guys, Prabir, that's done all these different roles. He was CIO, he's a CTO, CDO. I didn't get that on the chart. And now you're CISO. So thank you for being here. So we got a lot of information. And again, Prabir, he's kind of soft-spoken, doesn't like to talk about himself. So I'll talk for you. Man, you know data. I know that.
Yes, I do. That's my whole life.
You know data. And for those of you who don't know, I remember Spencer's Gifts. When I was young, we used to go there all the time. They had all the black light posters and everything else. But they also, such a cool company. They also have that Spirit Halloween store, which you also ran the data for them. And many people don't know it's the same company. And that's the largest pop-up store in North America. Well, it's like 3 months, right? 4 months, something like that, right? So, yeah. And now you're at SPAATech. You specialize in helping companies with their data needs. So we appreciate both of you. We got a great panel. So with that, let's get into it. We've got 3 categories to discuss: data, and this is all related to manufacturing, data, AI, and future innovation. So it's going to be fun. Let's get right into it. And the topic is AI Industry 4.0 and synthetic data. And how do you see AI impacting Industry 4.0 strategy, and what is the role of synthetic data? Who wants to start?
I'll try to kick this off. Thank you, Alex. So I've been in the manufacturing sector in some way, shape, or form for the past 30 years. So I worked with process industries and discrete industries. Those are really the 2 fundamental types of manufacturing we have out there, right? So, and one of the biggest transformations that happened in manufacturing sector was when the whole digital product development or collaborative digital product development happened in the late 90s, early 2000s. What that did for manufacturers was enabled the entire organization to collaborate in real time, cut down the cycle time for product innovation, for product creation, and then for product launch in the marketplace. Many companies, including some of the companies I was associated with, were able to cut their launch cycle time by more than 50%. So
that's huge.
Very impactful innovation. That was big in manufacturing. The next big impact happened when Industry 4.0 came about maybe 7-8 years back as a true strategy with frameworks and how companies can adopt it. So I am currently with Joyson Safety Systems, and when we looked at our digital transformation strategy, we actually adapted Industry 4.0 and we called it Joyson 4.0. So really, that was our internal digital transformation strategy, right? And a key bedrock of Industry 4.0 is how do you make your manufacturing assets much smarter so that they're able to communicate, collaborate with the decision makers in real time. This is really at the core of it. That's what it comes down to, right? Automation and real time communication with your assets, which was not possible before, right? And the key driver for that is the technology called IoT, Industry of Things. And then specific to manufacturing, we call it as industrial IoT. What it is instead of having chips that are programmed to just execute something, now you have chips that are programmed to execute, but also can communicate back in real time. This is really the big shift. That's what IoT is all about. Some of you may have seen in your homes, for example, your refrigerators now coming up with all kinds of innovations, like that's literally a control panel in most modern refrigerators that can check the temperature inside, that can actually check the quantity in your milk can and say when it is going to be low, and then it can actually send you a text message saying you need to buy milk. So this is one example
I
of
didn't know
how,
that.
yes,
Yeah.
this is one example of how IoT for the average consumer, we are beginning to see those kind of innovations. But as a manufacturer, what it means is in the past, I would have to run my manufacturing process in a typical production line. And then there will be manufacturing execution systems, MES systems that we call, that will have the ability to manage all the different controls in that manufacturing line. They collect a ton of data. They store all that data locally in some database within the plant. In case there is a recall, a safety issue, or a warranty issue, you need all that manufacturing data to prove to the government authorities that you are not at fault. So that is very critical. That's what we call as operational data in manufacturing. And then at a decision-making level, you have no idea what happens to that. All that aggregated data typically is sitting in some facility or maybe in some data warehouse somewhere. Prabir is all about data warehousing, so you can speak more to that, right? And then now with Industry 4.0, what has happened is we are able to integrate industrial IoT technology right into the production line. The lines are becoming smarter. The lines are communicating in real time. A classic example is in the past, if we have a capital intensive manufacturing asset in a plant, and these assets tend to be very, very expensive, right? A
You're
manufacturing
talking about like the machines that make
machines
these things.
themselves, a machine themselves.
Yeah,
right?
yeah,
And so they have to be running 24/7,
yeah.
365. Otherwise, you're going to lose money if they don't
Right.
work. And so we have a lot of preventive maintenance protocols on how to make sure we are checking these things constantly and making sure that we are ordering replacement parts if something is going to break, things like that. Now, what we do is we don't do preventive maintenance anymore. We do predictive maintenance.
Proactive, predictive maintenance.
Yeah, proactive and predictive maintenance. This is where AI comes in. This is where machine learning comes in. And what this is doing now is once you codify the process, this is actually monitoring those assets in real time and looking at how many hits they are doing, how many execution cycles they're executing, what is the replenishment cycle, what needs to be serviced when. It is predictively managing it. It is proactively managing it. Another big example of Industry 4.0 AI in manufacturing is energy management. This is a huge one. We are now using AI technology, Industry 4.0 technology in the plants to reduce our energy consumption by as much as 60% in some plants. And there's a huge cost savings to the bottom line of the company. Just to give you some examples, I'll now pass it on to Prabir.
That's great. I mean, you said a lot there. So a lot of changes have gone on, and they continue to go on. Let me ask you a quick, short answer on this one. What's the difference between manufacturing 4.0, which is what I originally learned about, and industry 4.0? What's just the quick difference? And then we'll go into more of the data stuff with Prabir.
Industry 4.0 is a much broader classification, does not necessarily apply just for manufacturing, right? So I can take an Industry 4.0 framework and certainly apply it to manufacturing, which is manufacturing 4.0. But I can also take the same framework and apply that to consumer packaged goods, which is an example. I can apply to transportation systems. I can apply to logistics management systems. So there are many different ways because Industry 4.0 at its core is all about industrial IoT, machine learning, and artificial intelligence. Those three come together. That's what Industry 4.0 fundamentally means.
That's pretty cool. I got to start studying that one. Prabir, now we've got that with that intro. As a data expert, how do you look at this, and how do you see the chart says synthetic data, but just overall, how do you look at this from a data perspective?
Yes, I think Nathan is expert on this manufacturing 4.0 and industry 4.0. The key engagement or key improvement is trying to do is through applying the AI, right? And how quickly the informations would be coming to the decision maker or making the decisions or predictions around whether it is a process, whether it is a device, performance, efficiency, quality of the product, all those things. So key things is how quickly the data is coming in to the place where it's supposed to go. And AI is creating that information. If I go back to the in days, 20, 25 years before, when I first time generated our software tools, which was taking from creating the machine load planning for the manufacturing industry. I'm talking about the Philips, the industry. So we are developing the machine load planning so that people can do the planning of how much molding they have to do, what raw materials, blah, blah, blah stuff. But that was feeding through the manual process, means only the machines was giving that, and the people are putting in things like that. Now in this manufacturing 4.0 or the AI is a later point of time, but in the beginning is having the sensors based or edge computing based systems to establish so that we can get those data as soon as it is generated and comes to the place where it can be decision making. AI is making this more, I would say that more efficient way and quicker way, because it can handle multiple criteria, which Jason was mentioning about, right? And different types of criteria require to determine that whether this is running efficiently or this needs to be done beforehand, not at a reactive basis, right? So those data point is the key, and that data point, as soon as industry produces that data and effectively utilizing it, and then that comes into how you organize your data in the organizations, and it will be you can have the multiple facet of discussions about how this data would be organized in the organizations, how this data will be distributed in the organizations, how this data will be communicated between the different production lines or different stakeholders, things like that. So these are all integrated, but it starts with how effectively we are generating the data and how effectively we'll be communicating the data at a later point of time.
And if I may add a little bit to that, Alex. So there are
sure. Thanks, Prabir.
Certainly, there are two challenges with AI and ML, machine learning. First one is to kickstart the process, right? If we're trying to implement these technologies, let's say in a manufacturing facility or manufacturing process, to kickstart the process, by definition, these things need data to learn. If they don't have massive amounts of data, they cannot have good high fidelity models that are predictive enough in nature. So most companies manufacturing will have that challenge to begin with, because manufacturers are very protective of their data. I don't want to share mine with my competitors or with my industry at large. My customers certainly don't want to do that. My supply chain does not want to do that. So unlike let's say a finance sector where the data is massive, or consumer sector where the data is massive, retail sector where big data is collected and being sold across the universe. In manufacturing, data is not widely available. Some data is available in mass, but not most. So that is the first challenge, and we'll talk about synthetic data later. The second one is, once we implement Industry 4.0, once we implement AI, ML technologies, now you are also collecting data, right? And when you collect data, what that means is we collect two types of data. One is operational data that we will talk about, and that is transaction based. We always collected operational data. We'll continue to collect operational data. Second one is analytics data, which is typically collected by polling a plant or by polling a line. Now, what matters is the frequency of the poll. So let's say if I can do it every second, now I have almost real-time models that I can generate because I'm quite literally collecting all the data that the plant is delivering. Most companies cannot afford to collect data in near real time, like every second or millisecond. If it is a mission critical system, they have no choice, they have to do it. Otherwise, most companies will collect data every maybe a minute, every 60 seconds. In our case, we really cannot even afford that. So we tend to collect every 5 minutes in our plants. End of the day, it doesn't matter what the frequency is, it is still going to generate massive amounts of data. And a lot of that data will be noise that you really don't need. So now a whole category called edge computing has come in. And what it is doing is it's basically sitting inside the walls of the plant, walls of the manufacturing facility at the edge, so to speak. And its job is to kind of filter the noise out or process as much information as it can within the manufacturing facility and then only push what is really needed down to the AI engines or the AI algorithms at the central level so that it can make decisions. So this is also emerging industry within manufacturing at this point.
Wow, there's a lot going on. So I had this, I want to ask you about a little more about synthetic data, then we'll go to the next slide. But before I do, it sounds like what I'm hearing is that there's an entire, who's mapped out. I always think of an architectural grid or what's called enterprise architecture when I hear these kind of conversations, where people have mapped out the entire enterprise. This is how everything works. It sounds like people are mapping out this for the industry, and then they're mapping out how their company will change to manufacture and sell and ship, how it fits into that new industry. And is that happening where when you say industry, is it a concept, or is there really companies that have mapped out, here's what manufacturing is going to look like?
Yeah, so you're talking about industry reference models.
Yeah.
Right. So in the past, by past, I mean, looking back in my career, maybe around 2007, 2008-ish, we still have those because they are still published standards. We call them as design chain operational reference model, DCORE, value chain operational reference model, VCORE, and supply chain operational reference model, SCORE. These are the big three, right? So companies that were doing process reengineering or implementing enterprise architectures would take those reference models and then compare their process and then try to adjust it. Some large companies, when Industry 4.0 first came about back in 2008-9, I'll use Siemens as an example because I used to work for Siemens. They designed their own reference model architecture. It was a seven-layer architecture. So what does that mean? It will start at the highest level with the corporate process, the enterprise processes, finance, manufacturing, HR, so on and so forth, right? So, but it will go 7 layers deep. And at the 7th layer, it will actually tell you what the data attributes need to look like and how they should interact all the way up. So some companies did a very good job. Siemens, in fact, industrialized it through their Industry 4.0 initiative back in 2009, and many companies around the world even today use that model. But this was before generative AI came into the picture. Traditional AI was accommodated in that model. I would say traditional AI, traditional machine learning was happening even in as early as 2010, 2011 timeframe. So that was accounted for. But this whole concept of generative AI and natural language processing and empowering the business to make decisions, because you are really simplifying technology. That's what you're doing when you bring these tools in. So now this is opening up a whole new world of possibilities.
Well, I see in my head, and then we'll move on. It seems like where we're headed to is, I've heard this concept. I remember 15 years ago, Prabir, you may have been one of those conferences that I ran about digital transformation. I forget which CIO came up and he said, there's a vision in the future of the fully autonomous company. And I could see, I've read things about the fully autonomous manufacturing plant. So it sounds like that's a bigger vision that we're kind of headed towards. I don't know if it'll be fully autonomous. That doesn't make any,
I mean, I
but in
can tell
terms
you,
bigger chunks of it,
I can
bigger
tell you
chunks of it.
that is our group chairman's challenge to us.
Uh, yeah.
He's telling every time we meet in a board meeting, he says, "I want 24/7 lights out manufacturing, 24/7 lights
We
out."
all want that. We want that
right?
for you.
That's what you.
Yeah.
So we are getting there slowly. Now we have smart factories. So a factory has become much smarter than what it was 10 years back. Now we have to get to that next stage.
That's
the
cool.
challenge is always investment, but technically it's possible.
That's cool. So let's move to Prabir. Prabir, I want you to explain for us what synthetic data is and how it's used, because we talked about, Nathan kind of gave you a preview in manufacturing, how some, they don't have as much shared information as other industries. How do you, as a data expert, data scientist, chief data officer, how do you use synthetic data? Explain that to us.
First of all, what's the synthetic data, right? It's basically you are mimicking all of your data which you have in the systems through a model. So model will create this synthetic data, and then you apply all of the different attributes and factors on top of it, and then define that what will be your final outcome you want to get from your synthetic data. And so the model will help you to create the synthetic data based on whatever the factors you want to do. So synthetic data is generated through the AI model, and then apply the synthetic data into your real life situations which you want to apply in your manufacturing process. And so I would say that it's a model based, QA data, your testing data, you're producing it.
So once you create the model using synthetic data to train it, does it then feed in the real data?
No, synthetic data is the data which you're creating it for creating your model afterwards. Yeah. So you basically don't need to. So if you look at that, the way the model works, you have the data, and then you train the data, and from the when you're training the data, you apply different criteria, and then create a model for you, and then apply that whole data into the model, right? So in this case, what you're doing it is, let's say you do not have enough data, or you want to do a different new process you want to establish. And when you want a new process established, you are creating those synthetic data from the data which you have, and then create a synthetic data which is not the real data.
Got it.
Right.
And I can give one example, because we just
so I think he has the example, some of them. So that's the core things of it's basically you are creating artificially, you are generating the data which is you can leverage and train your model.
I'll maybe give one example, Alex, to kind of put it in context. And as you know, I'm also heading our corporate AI strategy, and so we have kickstarted several initiatives, but I'll use one particular pilot we are running right now to kind of give the context for this. So computer aided engineering, CAE, in other words, modeling and simulation, that's what it is, right? So the idea behind that is, before you create something physical, you create a digital version of it with all the attributes, so that you can test that model to make sure it meets your noise, vibration, harshness, stiffness, heat, all the conditions that you need the product to meet technically, so that it can be manufactured to the customer's specification. This is the challenge. CAE does it reasonably well. You create the model. Once you create the model, you can test it, and it will tell you, yep, you're off in your NVH, or you're off in your energy consumption, or whatever, and then you tweak the model. So you can digitally tweak the model until you get everything right, and then you create the physical prototype, test it, and then you actually create the real part. That's how traditionally we have done it. With AI, now we have AI technology very specifically focused on modeling and simulation that can come in and create multiple models, multiple digital models, not one, but multiple digital models. Obviously, the more you can create upfront and test, the better your product quality is going to be. And typically in the past, to create a product, we would maybe go through 5-6 CAE models, right? And each one is very, very time consuming to create, very compute intensive, because each CAE model is a huge mathematical model. So it's very data intensive, and requires a lot of specialized skill set. It is not, you need to be at least a master's or a PhD to create and manipulate those models effectively. With AI, now the potential exists for creating almost 100 models within a week. That's what the technology is promising. So
Yeah.
we were really excited. We thought we had a ton of data because we have been doing CAE forever. And so we brought in two vendors, and they did the initial assessment to try to learn from the data we provided, because it has to first learn. Only when it learns, it can execute. So the learning process, when they went through it, they came back and said, you guys don't have enough data. We thought we had plenty of data. They said, you don't have enough data. Our AI model needs 60% more data volume to learn effectively. So this was the challenge. And then we said, how do we create 60% more data? Where do we go beg, borrow, and steal this additional CAE data? We could not, right? So now comes synthetic data. So now you work with the vendor, you work with their AI. It knows what our real data looks like. There's 40% data available. And then we work with them to create this synthetic data to fill that 60% gap, right? So now you got a hopefully 100% data. And then the more you create, the more data you create, the more it feeds the engine and it keeps getting better. This is how synthetic data works. The problem is it is fabricated data. It is not real data.
Yeah.
Right. And so, and the algorithm is learning through that. So there is a high probability of bias. There is a high probability of hallucination because your data is not real. A big chunk of your data is synthetic. A real world example of this, not typed to manufacturing, that most people can relate, is you've heard stories about somebody tried to automate something through AI and it did not, this was a university, it did not admit certain races of people. Because in the synthetic data, that race was not even represented. So when the data does not even have visibility into that particular group of people, and when you submit the application, they looks at it and says, this must be a fake person because this profile does not even exist from the data that I learned.
Yeah.
And it rejected candidates. So there's always the hallucination factor that we have to be careful.
That's so fascinating. Let me add one comment here, which is kind of interesting, I think, maybe. Just reminds me of Jurassic Park. Remember when they're doing the tour in the laboratory, and they're describing how they have the DNA. They have the DNA formula for these different animals, which they're able to get from the bones. And they said they had to create coding. They didn't have it all. So they created code and put it in there. It's the same thing. And as a result, they created dinosaurs that didn't have to mate, or they changed so they could have kids, baby dinosaurs, which grew up to be mean dinosaurs. And so the whole point is, I hope it doesn't turn out like Jurassic Park.
There certainly will be unintended consequences for sure. But
yeah,
if you look at it from the long-term view, you are going to generate more data. The AI is going to get access to more and more real data. Eventually,
as it goes,
the synthetic data percentage will shrink, and the quality will improve.
Yeah, I think another key aspect of the synthetic data, why we need that one. Most of the companies, when they generated this data, when they started this AI journey, they didn't know that they have to keep those last 20 years of data in the system.
Yeah.
Because they didn't know that they will be using that, right? They are most probably having a 1 year of data, 2 years of data, which is basically required. And I know that I worked with one of the CEO, and he says, "Hey, why we need this much infrastructure? Why need 10 petabytes of data? It's costing me so much. Just keep only the 1 month of data, right? Just 1 month of emails or things like that." So, and at the same time, he's asking, how can I use the ChatGPT and AI in our company? How quickly we can do that? So totally forgotten. So that's what this is kind of a patchwork AI companies is establishing with the companies, is saying that, okay, you give me whatever you have, Then I create a model to create additional data for you, and then put it all in the context, and then give you the solutions for the future model. The biasness which you're talking about, right? That if you have any biasness for certain time in the past, you will continue to be having that biasness in the synthetic data in the future, unless you inject those, remove those biasness from your synthetic data through your model. So that is what I think
the model
Nathan
has
is
to
referring
take into account the new data that's being created.
Yeah. So all the things which are in future you want to establish, making sure that anything which you have in the past, which you don't want to carry, I believe you want to do it in a future in a better way to run it, right? Not the way which you have been running before. So all those considerations upfront is really critical when you are generating your synthetic data as well.
Yeah, but also one more point before we wrap this up is, yes, this presents a lot of challenges, the data challenges and whatnot. Multiple industries. I talked about edge computing industry. Now we are beginning to see most companies offering infrastructure as a service. Dell just launched Apex. So Microsoft, Google, AWS, they already have things. SAP just launched Rise a few years back. So that energy is evolving. But for customers, what's critical is this is why now most companies are investing in chief data officers and data scientists for customers. Mm-hmm. If you have the ability to collect all this data that you historically did not collect, including, and this is critical, including data from your consumer after the product has been sold to the consumer, right? So now imagine I'm creating a car, I'm selling the car, and the customer is driving the car. I'm still getting data from that car because I still have IoT in the car. It's communicating to me directly what's going on, including where the customer is driving. So now OEMs, manufacturers are collecting a lot of data that at this point in time, they don't even know what to do with it, but everybody is trying to figure out how to monetize this data and create new revenue streams. So we are just at the surface of that. I expect that to also really blow up in the next 4 or 5 years because there is money behind it.
Yeah. Companies can you tell a very big business value here, right? Yep. Nathan, that's a whole new topic of how you capitalize all the data you collect. Every company can be I would say a provider of the data. Every company.
Walmart is doing it. The social media companies are already doing it. That's what they sell. But everybody can be doing it. That's what you're saying. It's great. That was a great discussion. Why don't we continue on the topic of master data management and data readiness? And so we were talking about the challenge of getting prepared for AI and in the processes. So how can manufacturers actually establish the robust master data management practices to ensure data consistency, accuracy across interconnected systems, supply chain systems, and also this future that you both were describing?
Yeah, I can give just a real quick, because it all comes with all the data challenges which you talked about in the before. Earlier, right? In an enterprise, Nathan gave an example of the Siemens, how they did in up to 7th level down, right? And how we propagated up. And one key point which Nathan mentioned about is whatever the deepest level data is identified and making sure this data is utilized all the level above, right? So that's the promise of the company's data readiness is, and it directly tied with the master data management, which is in a very big word. But the point is that having that link all the way across the enterprise for any data is used, lowest level, and understood and utilized throughout the organizations in every process, every areas of the utilizations of the data distributions. That I would say I would stop in there, and let's Nathan, I think he has a really good example on the manufacturing side.
I'll add a very, very quick example to kind of give some context and try to keep it short. So what is master data management? I'll just simplify it, right? So if you are an automotive supplier, let's say, And I'm using automotive as an example because I'm very familiar with that industry. You're dealing with multiple customers around the world. Same customer, multiple locations. Now, depending on each location, so let's say I have a plant in Germany and I have a plant in Brazil. And BMW is my customer in Germany. BMW is my customer in Brazil. Customer ID, an attribute. We're talking about data. I'll use one very simple customer name, customer ID. In Germany, we could be using a completely different set of systems. In Brazil, we could be using a completely different set of systems. They may have completely different nomenclature, and they may call the same customer different names, different IDs based on the systems practices in those regions. So when we say master data management, we're talking about how do I come up with data normalization across the enterprise? How do I define a data schema structure, a data dictionary, and a governance framework? It could be people, it could be tech tools, it could be technology, right? But a governance framework to synchronize and normalize my data definitions so that when I'm searching anywhere in the company for BMW, I get the same customer ID, and then maybe I get different locations where the customer operates. This is one example. And for manufacturers, again, I used this MES example before. So if you are manufacturing and if your product needs to meet industry regulations, and every manufacturing industry has different regulations, so I will not go into them. You need to collect a lot of operational data that we talk about, traceability data in particular. What is traceability data? It is actually tracing your product from the source to the delivery. That means from the raw material you use to manufacture the individual components, because there are compliance requirements even around material homologation in this manufacturing sector. In some countries, you cannot use certain materials, period. All the way down to every single step of the manufacturing, traceable, completely traceable, and for every single product, which batch, which lot, which shipment. And in most manufacturing companies, because manufacturers typically tend to grow by acquisition, right? We acquire somebody here, we acquire somebody there. They come with their own systems. Changing systems is expensive. So we say, hey, if it ain't broke, don't fix it, right? It's working. Yeah. They're making the product. Don't try to mess with it. You will find a huge mess in most companies when it comes to traceability data management. This is one big use case for master data implementations.
Yeah, makes sense.
Yeah, I think what Nathan is saying, I'm just going to add and make it in a more, in a formal way, saying that what is Nathan is mentioning about is basically data silos across the different organizations.
You spoke about that.
Whether it is a organically grown company or having their own geographical expansions, different cultures, all those things. So basically, he's talking about that how these data silos talk each other a common cohesive way. It's like finding a language which everybody will understand, right? And through the standards, through the governance, through the different process. So establishing that standard. That's all about is the MDM, and the data readiness is something different, which can be applicable for each of the data silos. They can create the data readiness on their own, but when it comes to enterprise, then that's the time MDM comes in to integrate all these data silos in a various ways. There's all the different ways. We don't want to go right now, but there's a lot of different approach, a lot of different framework to do that.
Yeah, I've heard you talk about data silos before and the importance for the future of companies to get away from that. We talked about that with Tom in our last conversation. And so it seems to me that is a key to the vision that you all described a few minutes ago about this, industry 4.0 and manufacturing 4.0. Seems to me this is a real big key to that. For the pieces to talk to each other.
So it is, but what has changed in the last 5 years from a technology standpoint is critical. So in the past, if you want to do an enterprise data warehouse with fully compliant master data management and data readiness in the whole 9 yards, what the consulting companies will do is they'll come, they will analyze all the data sources, they will try to normalize the data. They will create a data
Oh,
warehouse.
I
They will
get it.
migrate.
Yeah, that makes sense.
Now what is happening is different. Now technology vendors are telling us, I understand you got all these distributed data sources, and trying to consolidate, move, combine everything is going to be a huge challenge for you as a customer. Don't worry about it. You leave the data where it is. Leave the data where it is. We will focus on defining the business rules that you want to use. We will connect to the different data sources, to the different silos. We will never duplicate data. This is critical because the moment you duplicate, you are creating another huge data set, another huge warehouse of data. So what they're promising is that in real time, all of this will happen. So you magically kind of get normalized, beautiful data.
So
Right?
the AI is going to understand the difference.
Yes. So this is the big promise. I have personally tried 3 different vendors so far, and I'm yet to see that promise become reality, but hopefully it is coming.
Is there a company called the Tower of Babel? Babel? Hey, there's your new company name.
Okay.
The Tower of Babel AI data normalization system. So that's what you're saying, basically. You got all these different language data sets trying to get them to talk to each other, and the AI is going to be in between. That's their vision.
Yes.
Boy, I wish I was a sales rep selling that. Boy, I bet they're making a lot of money right now.
Those companies are all, making huge profits right now. I don't want to name anyone in this.
Yeah, it's a hard. I think what Nathan just mentioned, right? Keeping the data everywhere in as is, and then giving them the business rule, how they will be talking each other, and agreeing on that business rule with all the stakeholder is the challenge. And I think I did talk about several times in earlier, these cultural things comes into play. It's not just on technology, not just only data. It's all the cultural things would be coming into play to make it successful.
That's really interesting. I'd like to be that one sales rep who sells all the 10 deals, 20 deals. Then he goes to the next company, sells them again. Well, the first company's trying to clean it up. Yeah. We all know that. We've been there. All right. Is that all you want to say on this topic? Otherwise, we'll move to the next one. We good?
I think enough said. Yeah.
All right. So the next topic, we're still in the data area, is operational data management and integrating data ecosystems. I think we were just kind of talking about this.
Yeah, we just talked about it.
Yeah. Is this the same topic?
The integration part we talked about. Operational data management.
Yeah.
I give some examples on what's happening when what is operational data, right? So when we say operational data, that means the data that is being created transactionally as you execute your business operation, whether it's HR operation, finance, purchasing operation, and more importantly, a manufacturing operation, right? So I'll just focus on the manufacturing operation for this topic. And so manufacturing operation is what's happening within the 4 walls of a manufacturing plant. That is as basic as it gets. And if you look at the systems that are running the plant, you will have some type of ERP system, enterprise resource planning system. You will have some type of MES or IoT or a combined MES IoT type solution in the plant.
Yep.
You will have supply chain and logistics systems. At a minimum, you will have these systems. Some plants may also have some CRM relation systems to manage customers, because customers often try to get involved with their suppliers in the manufacturing process. So these are all the systems, and they're all generating data. And sometimes these systems talk to each other, sometimes they do not within the plant itself. And more importantly, if a company's got multiple plants, they often do not talk to each other at all. Now, what is the impact of this? I'll give an example. So I think we're all familiar with the tsunami that happened in India, the earthquake that happened in Japan, natural disasters like the LA fire recently. Natural disasters is a reality, global reality these days. When that happens, if I do not have visibility into my data landscape, operational data landscape at a global level, so I can understand like a cockpit almost. I can put a cockpit for each plant and say, okay, what's going on in each plant, right? So and I can see the complete cockpit view of my enterprise. If I don't have that kind of visibility, and some disaster hits a facility, it could be a supply chain disaster, parts are not coming in. If I have access to this, I can pretty much in real time shift my capacity to some other plant. In real time, we can do it.
Yeah.
If I don't have it, I'm stuck. I'm sitting there waiting. This is a big issue for companies these days. I'll just stop there.
Is this vision on a monitor, or is it a room with all kinds of stuff?
This is there are vendors out there today that have actually delivered these solutions to the marketplace. We have in fact implemented this in parts of Europe and parts of Asia in our company.
Yeah.
Yeah, I would
go ahead.
I would curious to see how you do the plant activity to move one place to another. But I do agree on that. Operational transactional data is basically we are trying to capture any event is happening in any business functions within the organizations, right? All the events is happening in any business to capture that and making sure it reach out to certain place. And that's what we have so many ERP and other custom tools, system. Now they have their own way to present the data. They have their own way to capture the data, and obviously they are not meant for to interoperate between the one system to other systems. The companies has to work on to do that, and that's what it comes into the vendors, which is coming in. A lot of companies like us, giving them the opportunity to look at the options, which was hard earlier when you have the data center based, but when you are now cloud based and having those options to have a hybrid environment and cloud environment and making sure that they capture the operational data in a way it reaches to certain place and having available to the other place where they wants to shift in case some disasters happen in one place to go the other place, which was hard. I remember that 15, 20 years before it was real hard to transactional replications of the informations to one place to another. With this new technologies, with this new framework, these things is becoming much easier and easier to have these ecosystems integrations and having at the same time the business continuity plan built around that.
Again, to kind of give a context, we went from databases to data warehouses to data lakes to data estates to most recently what we call as data fabrics. And fundamentally what it is how much you want to aggregate the data versus how much you want to stitch the data together in some way so that for the customer, the consumption of that information to make business decision becomes easier without incurring a huge overhead to get there. This is really the bottom line.
It's a lot to this. So we need guys like you.
Yeah, I don't want to go into it a little far. I think data fabrics, the modern technology is called data lake warehouse. So, which is warehouse and the lake blending, having all sorts of data available to across the organizations and distributed depending on the governance which they put in place. I will just put that way.
Yeah, I mean, to just give you the big three, like Microsoft, Google, and Amazon, the big three cloud vendors, they are investing heavily in this particular field. All three of them. The product roadmap is all focused on this.
It's pretty amazing how these companies that started in different topic, but one direction, are now also massive technology providers. It's pretty amazing to me how they've evolved. So it's pretty cool. Okay, well, let's keep moving. All right, I think we've already covered some of this, but let's cover some fun stuff. What are the most significant ways AI and other advanced technologies that you see are going to transform manufacturing processes and distribution over the next 3 to 5 years, 10 years, and even farther in horizon? Like, what's in the future? So for example, do you see AI-driven consumerization, autonomous manufacturing in our future? Go ahead.
So I'll start quickly and give you some examples that we are dealing with. Of course, there are cross-industry use cases of AI, right? So there are implications for purchasing, for for finance, for HR, and things like that. So I will, or even for technology organizations that support manufacturing. So I will not go into that. Specific to manufacturing. So when you say manufacturing, you're talking about first coming up with a concept, then creating the design for the concept, then testing the concept, making sure the design works and it is manufacturable, and there's the raw material actually available to manufacture this to meet the specifications that you're looking for, and then coming up with the manufacturing engineering so that you actually engineer the manufacturing process, the tools, everything that you need, and then you actually procure the material, procure the tools, kickstart the manufacturing. This is typically, you do some testing, quality testing before you actually do it, and then you do some quality testing after you make the part. Fundamentally, this is how most manufacturing companies operate.
Yeah.
And across the board, so starting with concept design. In the past, there were great innovators who came up with great products, ideas. Now, with generative imaging technology, not generative AI, with generative imaging, I can quite literally go into a gen image technology and ask a simple question like, hey, I want to design a car that does not have a steering wheel, but still can navigate. I'm just giving an example, right? The damn thing will actually come up with a design for you. It will. It will not be perfect, but it will. So on the innovation cycle alone, there are huge changes. There's now crowdsourcing innovation happening, meaning instead of one company doing it, they're throwing it out in the cloud and asking anybody out in the world to contribute their ideas. And the AI engine is learning from them, and then it's presenting models back to the company. That's on the innovation side. On the engineering side, I already gave you an example of what's happening in the CAE front, modeling and simulation front. I'll not go further than that. On the product development side, this is huge. Most products these days are becoming software-defined products. What do I mean by that? Every product has embedded chips, embedded technology in it. Most products are now beginning to try to figure out how to include industrial IoT in the product that they sell to the customer. So the product itself, when you say autonomy, that's what it is. Autonomy means software-defined product, software-defined manufacturing. That means the human intervention is gone. Software is making decisions using the product or using the manufacturing asset. So that means you now have to generate a lot of code, not just manufacture parts, but you're actually manufacturing software that goes into your manufactured part that you sell to the customer.
So the product can change.
The product can change. And
yeah.
So in fact, in our company, there are more software engineers in product development right now than there are in IT.
Gotcha. Cars.
Tons of code go into a car. So there's a whole bunch of software engineers in product development than there are in information technology. And so we are using again, I will not name any vendor here, but we are using technology that can actually help them create software much faster than they ever did. 70-80% efficiency we are beginning to see.
So Prabir, I know you got to run in a few seconds. So why don't you give us your thoughts on the future innovations from a data standpoint in manufacturing?
I would say not just only data, right? There is a lot of different front is opening up for innovations using the AI. And I don't specifically say about the data because the AI runs on the data, right? Without data, AI is meaningless. So they're harvesting data. What you would see in future is some of the things which is people are thinking about, like creating a smart factory, smart device, having communicate with the consumers and the manufacturers real time. So those things will continuously evolving. Even sometimes which is not possible earlier, like it's called like digital twins. So you basically simulate a plant before you go and create a plant, right? So you can do that in future with this AI technologies and with the smart synthetic data preparations way. and you will basically create the entire plant, whole things, and organize even the supply chain process. You can create the 5 different dummy supply chain and making sure that supply chain process all these things you create and create exactly how your future or plant will run, and you create that and then build it. It's basically just like creating a model before you create a plant. So those things is coming, right? Those are all the different things you will see would be eventually will be coming in. And of course, the automation portions, the more and more you will see that the automations, which is, I would say revolutionize the entire manufacturing industry. And that automations is becoming more mature. And you probably would be able to see that everywhere where you will look at, and there is a possibility that we can reduce the repeated process, the repeated work through these automations. And the key is that how you get this information effectively and creating the data effectively so that you can replicate those through automations and apply it in your systems. So I would say long term, and you probably hear that over and over again in industry, is the more we are doing harvesting this data and we are trying to do this or the digital twin or any other real-time communications with consumer, it requires a huge amount of computing power. So that means the sooner we reach the quantum computing or similar capability, all the things will go faster and faster, and we'll reach to that state which we are not thinking about now in 10 years period of time. Through this, all this processing power, computing power, we will be able to do whatever we are thinking about in just I spoke previously.
It's pretty interesting. You're both kind of saying some similar things in different ways. I see a vision of a car where you say, we're going to sell you the car one time in your life, and we're just going to keep updating it and replacing the components, and you're just going to give us a monthly fee.
Happens all the time with my car today. So yeah, I'll park the car and try to open the door, and then the dashboard will just go blank. It'll come back 5 minutes later.
Loading.
Software flash update. Yeah, happens all the time.
Well, this has been a fascinating conversation. Prabir, I know you got to drop, so thank you. We appreciate you being part of the community, part of our Board of Advisors program. And thank you for being here. Nathan, I want to thank you as well. This has been an awesome conversation. We appreciate both of you. We'll have another one. But I think
I would love to talk in a lot of in this area. I know we touched up on it on the top of the surface, right? There's just so much things we can talk about it.
Yeah, we kind of touched on digital computing and digital twins and quantum computing. That's a topic I would love to dive deeper. It is the future. So.
Well, we appreciate both of you doing that. Nathan, if you want to stay for a minute and give us your 2 cents on that, that'd be fine. Prabir, I know you got to go, but if it's all right with you, I'll get his overview real quick for
So lastly, thank you, Alex, for bringing me here, and thanks, Nathan, for the opportunity to talk on specifically in the manufacturing industry. There is a huge evolutions is happening across the data and the AI. The area which I focus on every aspect is making the enterprise ready for the AI, not to carry away with this thing. So that I would love to have a conversation in future, how the enterprise readiness comes in, given the fact that a lot of innovations is on our way. Thank you. I'll leave that way.
Thank you, Prabir.
Great job, Prabir. Sure. Appreciate you. Nate, thank you, Prabir. Nathan, hang on. I'm going to get you. What you wanted to add a comment about?
Maybe digital twin in particular.
Yeah, go ahead. Give us your 2 cents on that, and then we'll finish up.
So so digital twin is a very interesting topic. We have always had digital models, right? Digital prototypes. Even before you make it, you design it digitally, check everything. I talked about that. So what is different about a digital twin compared to these other things we have been doing for the past 15, 20, 30 years?
Yeah.
Digital twin is fundamentally different in the sense that it is a real representation of something that is physical. That means, let us assume us instead of manufactured product. Let's say I create a digital twin for me. Yeah. as a human being, I create a digital twin. This digital twin should know in real time what I'm eating, when I'm sleeping, what activities I'm doing, so it can continue to evolve itself to represent me physically. This is what a digital twin fundamentally means. That means you design a digital version of yourself, of the product that you're making, and then the product has to communicate with you in real time. This is where IoT comes in. Without IoT, there is no digital twin, period. So once you have IoT technology, right? This is fundamentally different.
You got the feedback.
You need to feed it. It has to communicate. Yeah. Otherwise, it is not a digital twin. It has to evolve continuously. So think a manufacturing facility.
That makes a lot of sense to me.
That is why it is called a digital twin and not a digital prototype. It is a twin of you, of whatever asset. So this is a big difference.
Wow. A bunch of stuff just popped up in my head. I can see that now.
I just wanted to clarify that.
So let's say, I like movies. So let's say there's a train system. I'm sure are they already doing this where they have the map of where all the trains are?
Yes, that is available. Yeah.
Okay. And are they digital twinning, or are they just using, they using checkpoints, and they're using radio or something to kind of guess where these trains are?
Yeah, they're using SCADA technology, they're using checkpoints, they're using GPS technology, they're using many other things today. But an example of a digital twin is let's say we're talking a lot about cars. So let's say you sell a car. Let's say you are a big car manufacturer, and you sell a car. You sell, I don't know, a truck. Let's say you sell 50,000 units of that truck, right?
Yeah.
Now, when you create a digital twin strategy, what it means is for every one of those 50,000 trucks that you sold, each one of those will have a digital twin sitting inside the company.
So the company is going to be monitoring every
so
car.
You will have 50,000.
And you subscribe to that. You give them the rights to do that.
Yeah, you have 50,000 digital twins, each one representing each physical product that you manufactured, each physical end item that you are selling. This is the difference about digital twin. And then once it is out, it is communicating back to its own digital twin, telling the twin, hey, this is what I did today, or I had these issues today. This is how much fuel I consumed today. This is my tire pressure. The digital twin is constantly updating itself. This is the digital twin, fundamentally.
Oh, dude! I mean, I'm a science fiction fan, and I had all these things coming up in my listening to where we're headed. So let me see. Let me ask you a question. Are you going to be able to do that with soldiers? You're going to be able to do that with, does it have to be a device? So I could see with the cars, I could see with the trains, with instruments in a hospital for sure. Anything that involves transportation, but is it going to involve, could it be people in a city?
It could be anything. In theory, a digital twin simply is a twin of a digital representation of something physical, number one.
Yeah.
Right. It has to be a digital representation of something physical, number one. Number two, it needs to know what that physical thing is doing in real time or near real time. So when I say in real time, that means IoT. If you have IoT is communicating constantly back. It's doing that in real time. If you don't have that, then we have many customers that may not have the ability or need for real time. Let's say manufacturing facility, the line is physically there; it's not moving anywhere. So they may not choose to communicate in real time. They may collect all the data, and then they may feed that data to the digital twin at a later point in time. That is also possible.
Oh, gotcha. So here's a batch of data for the last week.
Yeah, and the companies that are driving this primarily are what we call as PLM vendors, product lifecycle management companies. Those are the ones that are driving digital twin strategy for the industry right now.
It's going to be a wild future. Throw robots in there, we got a whole movie. So, and I know robots are on the floor right now, aren't they?
Yes, they are. Very much so, yeah.
Do you have robots?
Of course, yeah.
Do you have your own robot, like hanging out next to you?
No, not yet.
But at Joyson, are there robots, and what are they doing? Just clear about.
Yeah, we have robots. We have independent driving technologies that will deliver parts from one place to another within the plant. They move by themselves. They're like a little R2D2. They look like a
Yeah, the
little
little
R2D2,
R2D2s.
right?
Oh,
HEVs we call
cool.
them. So yeah,
Do they
so
chirp?
they drive through the plant and deliver parts. So we don't have people moving around with parts anymore in most plants. We have robots that are used for typically very repetitive technology that does not require skill set, right? So, for example, uh, when we make steering wheels. So in the steering wheel, you can either put a synthetic cover or you can put a leather cover. The leather cover typically is demanded for like the Porsches and the Ferraris. They want authentic, right? So they only use leather. Everybody else is different types of synthetic depending on what they can afford to spend. Most manufacturing facilities today, when we do synthetic uh, assembly for a steering wheel, we use robotic technology. We don't use humans. So that's pretty straightforward. When we use leather, it requires stitching, it requires a very specific eye to look at quality of the leather and many things. We use physical human beings, just to give one example. In most of our quality control, vision control processes, so we actually use robotic technology, laser technology, vision technology today to do product quality. So I'll use the leather as an example. So we buy huge, sheets of leather, and we flatten them, we process them, so clean them up, and then in the past they would run through this huge belt, like flat leather running through a huge belt, and we would have humans with these markers that look through the leather and say where the potential quality issues are. Patches here, patches there. They will literally mark it, so that when it is actually being cut to make the product, whether it's a seat or just to wrap something, they have to avoid those problem areas. We used to have people. Now we don't have people anymore. It's all vision driven. That's actually doing the assessment. There is no physical markup on the leather because it is capturing the whole leather, and it will tell the cutting system the coordinates of areas that need to be avoided so that you don't have to touch that.
That's
Just
amazing.
some examples, yeah. But
That's
in
amazing.
manufacturing, if you're a car manufacturer, there is heavy use of robotics. Without robotics, there is no car being built today anywhere.
Amazing. Well, this has been awesome. Thanks for hanging in there for a few more minutes.
No
Let
problem.
me wrap it up. And we'll talk about that next time, that last topic. But and we just did the additional thoughts just now. Unless there's anything final you want to say.
Yeah, the one thing I want to say,
Yeah.
just one thing I want to say, there's always been quantum leaps in technology.
Yeah.
So going
Yeah.
back to the industrial age and whatnot, in my lifetime working in the technology field, I have seen three major breakthroughs. First one was the evolution of the internet. This happened in the 90s and early 2000s.
Yeah.
Right. The next one was the evolution of the smartphone technology. Right.
Yeah.
This happened in the late 2010s, between 2010 2015. And I'm seeing the next major breakthrough as AI happening right now as we speak.
We're in it.
And we are in it. And what is interesting about all these major breakthroughs? These are generational breakthrough technologies. What do I mean by that? You can say very clearly, these were the group of people born before this technology came into place. These are the people who were born with this technology. So this technology is native to a generation of people.
To them. It's
their
native
culture,
to them.
their behavior, everything changes. This technology fundamentally is changing us. If you look at people who grew up with smartphones, the way they talk, behave is completely different from the people who grew up before smartphone. Same thing is happening with AI. 2025 is going to be the first year where there will be AI native generation that's going to be born. So their thinking will be different. The way they approach life is going to be different. And in another 5 years, I expect the fourth major technology breakthrough to really impact everything, that is quantum computing.
Quantum computing.
Right? We can talk about it some other time.
Yeah.
When quantum computing and AI come together, this is going to be a game changer, in my view.
It's going to be amazing.
It's going to be amazing.
Thank you for being here. Don't drop off when I finish off. I'm going to say hi to you for a minute. But thank you for being here. We appreciate you doing that. And everybody, see all of our videos at technologyexecutivesclub.com, plus our new YouTube channel, Technology Executives Review. We still got to load all the videos, but it's starting to happen. And then if you want to listen, if you're a listener, you can see our podcast, Technology Executives Review. That's the term we use now. It's on Apple, Spotify, and of course, our website. Thanks again to both Prabir and Nathan here. And don't forget to go to our site and subscribe to our newsletter. That's where you get notified about all of our interviews and get regular tips on how to elevate your own executive brand and more. And if you want to be involved and be a regular on our media network, like Nathan and Prabir, reach out to us and ask about our Board of Advisors program. Remember, the Board of Advisors in our organization is the Board of Advisors to the technology and business community overall. So book a discovery call on our site. Thank you for attending. It's an honor to serve you and our team. Thanks for everybody for being here. And again, thank you to Nathan and Prabir.